Flow.
Good afternoon. I'm Mosima ND, offering grade 11 agricultural science. I want to greet all the teachers who are offering the subject, all the learners, all the parents who are motivating the learners as well, who we are requesting them to motivate these learners so that they must work harder. Today, I'm going to deal much on the sections which are taking a lot of marks. If you look at agricultural grade 11, it is having about 4 chapters. The first chapter is taking 35 marks. The second chapter is taking 35 marks. And then the second chapter is divided into 2 categories, which means that it takes 35 marks plus another 35 marks. So that's why today I'm going to deal with soil science. And then you'll bear with me because of this COVID-19. I will cover a larger scope, which means that I'm going to run over a number of things which are possible examination tests. So my presentation will start with soil science based on the following key items. 1, soil texture. 2, I will also take soil structure. 3, I will take soil color. 4, I will take soil pore spaces. 5, I will take soil air. 6, I will take soil moisture. 7, I will take soil temperature. 8, I will take soil morphology. 9, I will take soil classification. 10, I will take soil colloids and acidity. 11, I will take soil alkalinity and salinity. 12, I will take soil living organism, organic matter. And the last one that I hope I will take is soil non-living organic matter. Now let me expand. Let me expand on these key topics, starting with soil texture. When we look at soil texture, by definition, we simply say is the coarseness and the fineness of the soil particles. Then it is very, very crucial, this chapter. It is one of those chapters that an agricultural man must understand it very, very well. So the first thing that I'm going to look into is how do we get the different textures. So when we want to get out and find out what are the different textures, there are 3 possible ways that we usually use. First one is what we call sausage formation. You simply go out, you moisten a bunch of soil, you roll it around your hand, and then if that soil can form a cycle, then you must know that that type of a soil is said to be a clay soil. If you roll that soil and it cannot form a cycle, maybe it just breaks towards a half, then you must know that this is not a clay, but it is now sealed. Then you can go further. If you try to roll that into a sausage formation, but you realize that there is nothing, then it cannot even form a half cycle. That it means that it is clay. In other words, what I want to say, there are 3 types of textural classes that we can talk of. The first one I said is clay. The second one I said is sealed, which means that it is in between the clay and the sand. The sand is there also, which is, and then if you look at, as I've indicated, that these particles are either coarse or fine. You would always realize that when we measure this thing, we sometimes use a sieve. We sometimes use a filling method. Then if, for an example, I say you want to use a filling method, you are not going to form a sausage. You simply go out, find the soil, take a bunch of soil, put it between your forefinger and your thumb, and you start to fill it. And once you fill it, you find that it is fine. Then you automatically know that it is clay. If you find that it is between fine and coarse, then you automatically know that it is what we call sealed or loam. Sometimes we call it loam. But if you find that it is so coarse, the particles are loosely packed, then you realize that it is what we refer as sand. Then the other important aspect on this item is where we use what we call the textural triangle. This is one of the key questions that we usually do, where you put these three soil classes, texture classes, on a triangular form. And then we want to get the analysis out of that particular thing, what it will tell you to do. So one other important thing that I want to emphasize on that one is the importance of finding the texture of the soil. One of the importance of finding the soil, the texture of the soil, is for an agricultural man to be in a position to can realize how the seed will germinate. In other words, I will talk of seed germination. I will also talk of water holding capacity. I will also talk of what we call the root development. And then I will also talk of the presence of pesticides, how they can move around in that particular particles. So the other important thing, when we use that textural triangle, usually we arrive at different aspects. Like we get sand, we get what we call loamy sand, we get what we call sandy loam, we get what we call loam, we get what we call sand loam, we get what we call silt. And then from there are also other things that we can say. For an example, we can talk of sandy clay loam, sandy clay, silt clay, and clay. So this is very, very important to an agricultural man, because this subject is a practical subject whereby the agricultural man must realize the importance of that particular soil. Then if I go to different properties, sometimes I can talk of the properties of sandy soil as well as the properties of clay soil. So key properties of sandy soil are as follows. 1, lower water holding capacity, poor for dry land farming, and then low organic matter content, and it is usually well aerated. Let me put an emphasis on what I've said. So we say you find that there is lower water holding capacity, which means that if your soil is sandy and then you are an agricultural man, you must realize that the movement of water is very fast in that. So the retention capacity of water will be very low. So which means that you must irrigate very often. Then there's another important thing, poor for dry land farming. If the area you farm in is dry, then you'll have a problem with this sandy soil. Then the other important thing is low organic matter. When you talk of organic matter is preferably dealing with the fertility of the soil, the presence of the substance that are coming from other organic substances. Then in sandy soil is very low because it's easily washed out. And then, but what is very key on this soil, it is well aerated, meaning that the air can move very well inside that. Let me quickly run through the properties of clay soil. 1, lower infiltration rate. In other words, what I'm saying when I say lower infiltration rate, I mean that when the water gets into this soil, it moves very, very slowly. And then also limit seed germination. In other words, when the seeds are supposed to germinate, or not all of them will be in a position to can germinate because the soil is so tough, poorly drained. In other words, there's this question of when you have water in the soil. With the clay soil, it is very poorly drained. And it is also poorly aerated. The reason why it's poorly drained and poorly aerated is because the particles are very clinched to one another. And then it has a problem of water locking. Usually when it rains, the water runs very, very quickly on top of clay soil. So definitely let me pause here on the question of soil texture. I will give you some few questions at the end of the lessons in relation to soil texture. But let me quickly run to soil structure. Soil structure, by definition, we usually say is the manner in which the particles are arranged. In other words, it moves from soil texture to structure. The difference is that now when we look at the soil structure, we look out of the patterns. We are no more looking at how fine or coarse they are, but we are looking at the patterns. How are they closely related to one another? So the first group of soil is said to be crumb structure. Crumb structure is where we find that the particles are very closely arranged or closely packed. And then when we say single grain structure, is where you find that the particles are loosely packed. That's where we usually define soil texture as what we call the aggregates. The other important thing with the soil structure, as I have already alluded with texture, there are types of soil structure. Usually the learners must know that we will bring diagrams of different types. I will give you only 4 of these. The first one, we regard it as blocking, which means that the soil forms, the particles forms a block. Then you will realize that we refer it as a blocking. The other one is what we call prismatic. The other one is what we call spheroid, which are shapeless, they don't have any shape. And the other one are in the form of plates, which are platin. Then there are certain important factors that influence climate, that influence the structure, which result, such things are climate, organic matter, tillage, and electrostatic forces that are playing a very important role. Then I continue furthermore with factors that influence soil structure. This one is usually man-made, what we regard as poor tillage, what we regard as poor practices, which we regard as compaction, loss of organic matter. All these are more influential in the formation of soil structure. Now, the importance of soil structure. The key importance of soil structure is when the seeds are to germinate, germination of seeds, water holding capacity, drainage properties, root development, and as well as pesticide movement. All these are very, very key. Now let me quickly run through the soil color. Once you move into any farm and you are an agricultural man or you want to farm, you must be in a position to can determine what type of a business you are going to do with that particular soil. So there are a number of colors that we can see and we will also interpret. For an example, we have dark color, we have red color, we have light color, we have yellow color, we have grayish color, we have mottled color. Let me interpret this so that everybody can understand why these colors are different. If, for an example, I take dark color obviously means that the type of the soil will be warm because dark colors absorb more heat. And then the other important thing, you will realize that this originated from organic matter. Organic matter, which are living things. And these living things are decomposed. And as they are decomposed, they then form a layer of dark colored soil. And such soil is usually fertile. So I would challenge everybody listening here that immediately you realize that the soil is dark, you must know that that type of soil is very fertile. Then you can produce whatever you want to produce. But don't forget the question of the texture and the structure. Then we have another color like red. If you look at red, usually it originated from what we call iron oxide. But nevertheless, that it comes from iron oxide, it is usually fertile, it is usually well drained, it is usually well aerated as well. Then we have another color I've indicated, light. If you look at light color, usually we can depict this light color on sandy soil, which means that it is well aerated, it is well drained. But there's a problem with this one. There is shortage of nutrients in the soil. It's easily leached. For one to farm with the light colored soil, you need to add some lot of organic matter. Now there's another color which I can refer to as an example of other colors like grayish that I've mentioned. I will take this one as the same color, the color yellow. If you realize that the soil is yellow, to an agricultural man, the first thing that you will come with will mean that the color has been changed from one to another. The color becoming yellow or grayish as a result of the presence or more time being waterlogged. If the soil is waterlogged, obviously you will realize that this soil will change color. Either would become yellowish or grayish depending on the type of the soil which is there. Which means that for an agricultural man to work on that type of a soil, you need to improve that color of the soil. Which means that you must work on that particular thing. You must do what we call drainage and other important aspects of that nature. So there are certain key factors that determines the color. For the color to be, there is what we refer to as organic matter. Large amount of organic matter will obviously change the color of the soil to dark. Presence of compounds and other elements. I've already alluded on iron oxide. If there is a lot of iron oxide, it will automatically make the soil to become red. Drainage. Drainage is where you find that the soil is always waterlogged. Obviously, such a soil which is ever waterlogged, it will become a little bit either gray or either yellowish or any other color which we can refer to as mottled color. Then another important thing is the question of leaching. When nutrients are moved out of the soil, then it will have another color. Now let me quickly go to the next one, which is soil pore spaces. This one, it might be difficult to an ordinary man to understand. But as I've indicated with texture and structure, we are all aware that the soil has been formed during a process called weathering. Weathering simply means when the rocks were broken down, they resulted in forms of what we call small particles. Now, if you look at the soil, you might not realize that there are spaces in between these particles. These spaces which are found in between these particles are regarded as soil pore spaces, which means that we have two types of these pore spaces. The first type is regarded as macro pore spaces. Simply, it means they are larger in size, which means that when they are larger in size, they easily allow free movement of water and air. Then we have another group which we call micro. The micro are smaller in size. Due to what I've already alluded in relation to clay and sand, you would realize that the macro are preferably found in sand and the micro are preferably found in what we call clay. Factors that influence the pore spaces. 1, soil texture. 2, soil structure. 3, soil depth. 4, soil cultivation. When you cultivate the soil, you influence that. Now let me move to another one. After I've indicated the pore spaces, I've said that in between the particles there are spaces. Now what occupies these spaces? These spaces are preferably occupied by two key important things. 1, water. Secondly, air. Then if you look at soil moisture, there are categorically 3 types of water which we find in the soil. First one is regarded as hygroscopic water. Second one is regarded as capillary water. And the other one is sometimes known as gravitational water or what we call free water. If I would like to elaborate on what we call hygroscopic water. Hygroscopic water is that water that is engulfed in between the micro particles. There is the soil and with the water which is not available for plants utilization. In other words, this type of water is there in the soil, but the plants will wither. Meanwhile, the water is there because it's not available for utilization by the plants. We can only realize that there's water there when we take this type of a soil to a laboratory and we do laboratory test. Then we realize that there's water, because I've said it is engulfed. It is not good for a human being. Then there's capillary water. This one is very, very important. It's the type of water which is available for plant utilization at all costs, because it is the type of the water that can move in all directions. It can move downward, it can move upward, it can move sideways. It always moves towards where it is needed. In other words, I would say it is moving from a higher concentration to a lower concentration. If the roots are on the side and they need water, the capillary water will move towards the side. If the roots are up, the capillary will move from downwards upward. If it is down, then it will also move downward. So that is what we call capillary water. Then free water or gravitational water, as the word say. The word gravitational water emerged from this word gravitational force. In other words, it's the water that can only move downward. It cannot move upward, it cannot move sideways. It just moves downward. And then this is the water which we find after heavy rains. The water will then get into the spaces, and then it keeps on going downward. And it doesn't matter whether the plant roots are up. As long as it had passed the level of the plant roots, it cannot be utilized by the plants, because it is ever moving downward. Now, the other important thing that I want to emphasize here, this I want to emphasize to everybody, people, we are living in an area which has got a shortage of water. There's shortage of water. The way in which we can lose soil water. Farmers would bear with me that there are ways in which we lose soil water. There are 4 possible ways in which we lose water. The first one is regarded as speculation, or sometimes we call it seepage. This is what we refer as the downward movement of water. What I said is gravitational water will then move downward. As it moves downward, we lose that that water completely, because at the end of the day, it will arrive at the water table. That we call seepage or percolation. The other important loss of water is what we call runoff of water. This I usually encourage farmers to be very, very careful when it rains. They must harvest the water, because in most cases we lose a lot of water through runoff. Runoff simply means that when it rains, the water flows to the streams, ultimately flows to the river, it goes to the river, from the river, it flows and flows and it's gone. Within 3 weeks, you say there's no water at all, because we have left the water running off in front of you. The other one is what we call evaporation. Evaporation is when the water is heated. Usually we know that when the water is heated, it changes from a liqueous stage into a gaseous stage, and it started to evaporate. And the other one is that which we lose through what we refer as transpiration. Transpiration simply means that the plants will absorb water from the soil, and then once they put that water into them, they transpire. In other words, they lose that water through what we call water vapor in that particular fashion. The other important thing is, how can one manipulate the water loss? As I have already alluded that we lose a lot of water. What can we do in order to keep this water, to use this water effectively and optimally? Because in our areas we have very little water. 1, tillage and shaping of fields. When we till the soil, we must work the soil in such a way that we does not allow percolation to take place easily. We must make sure that we mulch our soil in such a way that it will absorb more water. Shaping of the fields, like what we can regard as building of the contour walls. When you plow, don't plow along the slope. Make sure that you make borders. You make what we call humps, so that when this water is moving, it's trying to run off, it must be delayed by those humps. And as it is delayed by those humps, it then sinks into the soil. That's what we regard as shaping of our fields. We must not just use that traditional way of farming. We must make it a point that our fields are shaping that such a way that they will cap or disturb the water movement. Another one, as I've already indicated, is mulching and the use of vegetation. Let me explain this one of vegetation. I've said that one of the loss of water is evaporation. If the land is bare, the sun rays hit the ground easily. And then as it hit the ground easily, the water becomes warm and becomes hot and then ultimately evaporates. Then what we must do, we must make a cover. The soil must be covered with vegetation. In other words, we must plow, we must have plants that covers that, so that the soil must be in a shady place. Another one is shading and row spacing. For an example, when you plow, you must make sure that the plants are in rows, because they would compete for this water for transpiration. The other important thing is key prevention of water loss. We cannot prevent, but we can try. We can try to minimize. Sometimes we say prevention or minimizing water loss. 1, mulching. 2, the building of contour walls. 3, soil covers. Must make sure that we cover the soil. Another important aspect is the removal of weeds. Sometimes don't allow unnecessary plants to grow in your field, because they will compete for that very water. They will transpire that particular water that you need so much. Now let me quickly go to soil air. Soil air is also found in the soil. Basically, we have about 3 types of gases that are found in the soil. One, which is major, is what we regard as nitrogen. Nitrogen is in the soil, it makes plus minus 79%, which means that it is the one that is in bulk. And then you go to oxygen. Oxygen in the soil is making plus minus 20%. And then you go to carbon dioxide, which is making only 1%. In other words, it means in the soil, we have 3 types of gases, which is nitrogen, oxygen, carbon dioxide, and then all this with their percentages. Now, maybe for an example where we need, why do we have oxygen in the soil? Why we have nitrogen in the soil? They are very, very important. 1, oxygen is very key for the respiration of microorganisms. You will bear with me that in the soil there are living creatures, which you regard them as macroorganisms and microorganisms. They need oxygen for their respiration. Germination of seeds. Usually we put the seeds into the soil. They need this carbon dioxide to germinate. Decomposition of organic matter. They need this oxygen to decompose. And then oxidation, as well as weathering. Those are the key elements why oxygen is very, very important in the soil. Now, carbon dioxide. Carbon dioxide is also very, very important, because it's the one that works on the process of weathering in the form of carbonic acid. It is also essential for the process of respiration. Nitrogen, for the development of nutrients, for drainage purposes, and for aeration purposes. If we look at nitrogen, usually we talk of nitrogen cycle, which it is converted from one stage to another stage. Why is it used there in that particular fashion? That's why we say it's very, very important. Now let me get to the morphology. Morphology simply refers to the depth of the soil. The soil, if you look at the soil, is subdivided into 3 main categories. The first category is topsoil. The second category is subsoil. The third category is substrata. If you look at the topsoil, it's the soil that is usually found on top. And that type of a soil is preferably or dominantly made by the presence of organic material. This organic material which falls from the living things decompose on top of the soil and forms what we call topsoil, which is usually very fertile. Then we have the substrata. The substrata is usually between the subsoil is usually underneath what we call this topsoil. It's the soil that has got a large volume. In other words, when we talk of the soil depth, preferably we look at the subsoil. Then from there we have the substrata. Substrata, in sometimes we refer to as the parental rock or the underlying rock. Now let me get deeper into this. When you look at this three horizons that I've mentioned, I've mentioned topsoil, subsoil, and substrata. We can further divide it into certain major horizons, which are also we are also going to identify the differences. We have 5 major horizons. The first one is regarded as O horizon. The other one is regarded as A horizon. The other one is regarded as B horizon. The other one is regarded as C horizon. And the other one is regarded as R horizon. Now let me explain. If you look at O horizon, is the horizon that is made by fresh or partially undecomposed organic matter. So you find that some fresh living things are still on top of that particular soil, which is preferably dark in soil. Now when we look at A horizon, O horizon and A horizon are come together, forming what we call the topsoil. You would realize that some of the iron oxide are released from the upper layer going down. That's why we say this horizon is said to be a alluvial horizon, which means that some iron compounds have been released from the upper side. Then we go to B horizon. B horizon is forming the whole of what we call subsoil. This is the soil which has been enriched by those which have released from the A horizon. Then we go to the C horizon. C horizon is preferably part of what we call the substrata. It is what we call it withered rocks, or sometimes we refer it as unconsolidated rock material. In other words, you find that these are rocks, but these rocks are not solid, they are broken. That's why we say they are unconsolidated. And therefore, the root can pass through these rocks because they are unconsolidated. Then from there we have the R horizon. The R horizon is just a single rock. Sometimes I refer it as a consolidated rock, or I refer it as a solid rock. So those basically are the main horizons that we can talk of. Now, after I've indicated the ideal soil profile, I was talking in terms of the ideal soil profile, which is composed of 5 major horizons: O, A, B, C, and R, that we call ideal under normal circumstances. But it is very rare where you find normal circumstances in the areas in which we live. Other type of soil are eroded. Erosion simply means the removal of the topsoil. If one would ask you a question, give the soil profile of a soil which is eroded, it automatically means that the 2 upper horizons are not there. That's why we say this is a disturbed ground. Wet soil. Wet soil is a soil where it has got a lot of water. It is in most cases waterlogged. And then when it is waterlogged, the visible horizons would not be easily be seen in this type of a soil. Usually you would realize that you cannot see other horizons because the water spent most of the soil spent most of the time in water. That's why we say it's waterlogged. Then we talk of young soil. Sometimes we refer as young soil. The soil which is still developing, it might not have an ideal soil profile. Then we talk of an adult soil. Usually, adult soil is an ideal soil profile, which I have already alluded. Now, let me go to what we call soil classification. The soil can be classified into two major things. One, soil forms. Two, soil series, or what we regard as soil families. When we look at soil forms, this usually deals with the upper or the general levels, which is plus minus about 73 in the soil. Then we look at soil families or soil series. This is lower or specific, which are about 404 in soil. Then I want to emphasize the other one, steps, when we do what we call binomial soil classification. Usually we take soil classification. One, we demarcate the master horizons. Two, we identify diagnostic horizons. Three, we identify family marks. Four, we identify what we call soil family. The last one, we identify the texture. Let me say, after when I was talking of the soil profile, I said we have got 5 major horizons. Now, if we do what we call diagnostic horizons, the topsoil can be divided into 5 diagnostic horizons, and the subsoil can still be divided into about 15 diagnostic horizons. Hence we say, if you do all this necessary classification, then you will realize more about the soil. The other important thing that I want to emphasize is benefits of classification, of soil classification. Benefits of soil classification. When we talk of the benefits, what does an ordinary man or an agricultural man benefit out of soil classification? If you look at soil classification, it's very expensive, but the person will benefit the following things: organizes and facilitates knowledge about the soil, which is very key to any person who is doing work on the farm. You must have knowledge, so that you must know that this type of a plant cannot grow in this type of a soil due to this. So when we do soil classification, we organize and we make sure that we facilitate the knowledge about different types of soil. Another important thing is for an agricultural man to understand the relationship of different soils. The relationship of different soil. How are they related to one another? The other important thing is the establishment of groups for practical purposes. You know that there are a lot of things that we must do in practice, because some of things we cannot believe them. But because of soil classification, we are able to establish groups in which we can make what we call practical purposes. So sometimes when we do soil survey, we usually use this classification and other things like that. We must understand these different types of soil. The other important thing is the predict behavioral of different soil. When I say behavior, if you would listen to me very carefully from the beginning, I've been talking of different things that the soil is doing, that the soil is capable of doing, that the soil is not capable of doing, that we regard as the behavior. So we know that if, for an example, the soil is dark, I believe the agricultural man will realize that the soil is fertile. If the soil, you get into a farm, you want to buy a farm, you realize that the major part of this soil is light in color. You must forget about planting because the soil is poor in plant nutrients. So that's what I refer to as you predict what we call the behavior of the soil, what type of the soil. You must know that if such soil is there, you must make sure that you are going to lose lots of rents in order to improve the soil structure and the soil texture. Whatever you will improve, you lose a lot of rents. Now, the other important thing that I would also like to emphasize is the question of identifying the best uses of soil. This is key to agricultural man. I want everybody listening here to hear me very well. There is a need that we must use the soil optimally. The soil is one of the natural resources that we have. Usually it's a God-given thing. And then if you look at the soil, it has got certain key economical advantages. What we refer as the economic characteristic. Like for an example, where we say the soil is durable. When we say the soil is durable, it means that the soil is there forever. We can say the soil is indestructible. We can say the soil is there, which means that it is available at all costs. Wherever you go, the soil is there. That's why we say the soil is available. But you will realize that people will keep on complaining that this soil of mine is very poor because you did not do what we call soil classification. So when we deal with soil classification, the primary aim of that is to make sure that we use every soil, every aspect of soil to what it is required to be used for. For an example, we can say one of the soil characteristics or economic characteristics is such a specific environment. So if you did not do what we call soil analysis, soil classification, then you will have a problem where you find that your farm is mountainous, and you will find a man trying to plow maize on a mountainous area, which means that you did not do your homework very well. Then we go to the other important thing is the estimate of productivity of the potentiality of the soil. This one I would like to emphasize more. When we do soil classification, we want to make sure that the person who is utilizing the soil can make use of the soil to its maximum productive potential. It is very pity when you use the soil and it is not used up to its maximum potential. So when we do soil classification, we make sure that this type of a soil can produce so much. Like we know, one of the economic characteristics of the soil is that soil is subject to the law of what we call diminishing return. When we say the soil is subject to the law of diminishing return, and you don't understand it clearly, you did not make soil classification very well, you did not check your soil survey very well, you will have a problem. Because always you will want to pump fertilizers into the soil. So because the soil is subject to the law of diminishing return, it will automatically yield more production up to a certain level. Now when it arrives at that particular level, the soil will then start to deteriorate until it arrives to its normal productivity. It cannot produce over than that. That's why we say the soil is subject to the law of diminishing return. The other important thing is the transfer of knowledge. The transfer of knowledge. When we talk of transfer of knowledge, that this classification will make sure that knowledge is well transferred. Then let me wrap my things. There are learners, good learners. There are possible questions that we might get. 1, name and describe 3 main groups of soil particles. 2, describe factors. You can also have name of gases, texture triangle, very good, very important, that one. Interpretation of soil colors, steps involved in binomial soil classification. In conclusion, let me quote the Lord's Prayer, which says, "Give us this day our daily bread."